The question says a satellite with a mass of 617 kilograms is placed into a circular orbit 1.00 times 10 to the 7th meters above the surface of the Earth, which has a mass of 5.98 times 10 to the 24th kilograms and a radius 6.38 times 10 to the 6 meters. Calculate the linear speed of the satellite as it orbits the Earth at this altitude. What we're going to do is draw out the situation. So that's my representation of the Earth. And we're going to draw the satellite's circular orbit around it. So if we draw like the satellite here, maybe-ish, pretend that's a satellite in orbit, and it says it's above the Earth by 1.00 times 10 to the 7th. Okay, and then its mass is 617 kilograms. And if we draw like the satellite here, maybe-ish, pretend that's a satellite in orbit, and it says it's above the Earth by 1.00 times 10 to the 7th. Okay, and then its mass is 617 kilograms. And the mass of the Earth, they give us 5.98 times 10 to the 24th. And then they give us the radius, 6.38 times 10 to the 7th. You're probably wondering, well, what are we supposed to do now? Well, the centripetal force is equal to gravity in this situation because gravity is pointing straight down, like towards the center. And so here's the formula, which is found in our reference table. And we set it equal to the centripetal force since gravity is a centripetal force. We can use Newton's second law to help us with the problem. F net equals ma, and F net is gravity because gravity is pointing towards the center of the circle. So like, and then, so that is equal to, this is on our reference table, g m1 m2 over r squared. Mass, centripetal acceleration is v squared over r. So we carry this over and let's check if any variables can cancel out. All I did was cross out what appeared twice and then I solved for v. And we crossed out mass from both sides because the mass of the satellite appeared twice. So you're just left with the velocity equaling the square root of the gravitational constant, universal gravitational constant, which is 6.67 times 10 to the negative 11 times the mass of the Earth, since the satellites canceled out, which is 5.998 times 10 to the 24th. And make sure that you add from, because like the radius is the Earth's radius and like how high it is, because that's this whole thing. So that's why I added that. And now I will plug it into When I plugged it into my calculator, I ended up getting like this really long thingy number, but the point ended here. So you're just allowed to put that into scientific notation. So you go 1, 2, 3, and that's how you get the velocity equals 4.9 times 10 to the 3rd meters per second. What would happen if someone just tackled on another part to this problem and told us to solve for the centripetal acceleration? So we know that we have that formula and it's v squared over r. So we take our answer that we just found, 4.9 times 10 to the 3rd, and you divide it by our radius, which is 1 times 10. I realized I forgot the squared, and so I added parentheses. And then you get this really big long number, your calculator, and then I rounded into the tenths. So I ask you to find the period Well, we know that the period is 2 pi r divided by the velocity, so that should be a nice plug. And after I plug in, I get that the final answer for the period is 2.1 times 10 to the 4th.